Light, the cosmic constant, zips across the universe, painting our reality, carrying all information from seeing a friend to distant stars. Its instantaneous speed defines our now. But what if this fundamental pillar of perception crawled? How would that reshape existence itself? And let's find the answer to the question, what if? A dramatically slower speed of light would shatter our fundamental experience of reality, replacing instantaneous perception with a constant realm of lags and distortions. Imagine everyday life plagued by a noticeable visual delay. A simple conversation would feature a jarring lag between speech and lip movement, and a thrown object would visibly land moments after leaving the hand. All immediate interactions would be defined by this inherent delay. Moving through this altered world would evoke a perpetual, subtle, slow-motion flicker. Colors would dynamically shift with your velocity, while objects passing by would appear noticeably compressed or stretched due to tangible relativistic effects. Crucially, the very concept of a universal now would dissolve. Each individual would inhabit their own dynamic present, where information from any source, even nearby, arrives with an unavoidable inherent delay, rendering true simultaneity an elusive, impossible dream. This constant perceptual reordering would redefine our most basic interactions and understanding of the present moment. A dramatically slower speed of light would catapult relativistic physics from theory into our everyday reality. Einstein's iconic E equals mc squared would mean the energy convertible from mass is drastically reduced, fundamentally altering how stars burn, heavy elements form, and making nuclear fusion far less potent. Time dilation would become a tangible daily experience. Even a brisk walk could cause noticeable differences in personal time, impacting aging over short journeys. The universe's absolute speed limit would plummet, profoundly constraining everything from particle interactions to the very feasibility of any meaningful high-speed travel. This reshaped physics would redefine energy, time, and motion, unveiling a fundamentally different cosmos. With light crawling, our night sky transforms into a profound, living archive of the past. Distant stars and galaxies wouldn't just be spatial marvels, but temporal windows, revealing how they existed eons ago. We'd be observing galaxy ghosts, their current states forever beyond our immediate perception. Interstellar travel, already daunting, would become an ultimate test of sacrifice. Any journey, even to nearby systems, would propel travelers deep into their own future due to extreme time dilation, making return to their home timeline impossible. Furthermore, our observable universe would shrink dramatically. The sluggish light from truly distant cosmic wonders might simply not have had enough time to reach us since the Big Bang, regardless of how ancient they actually are. This would present a paradox, an ancient, vast cosmos appearing strangely small and isolated to our constrained vision. Redefining technology in a slow light universe would revolve around bridging immense lags. Electronic communication and computation would face an unprecedented information bottleneck. Global networks would suffer extreme latency, making real-time interaction across distances impossible. Computers themselves would be massive, slow, and physically constrained. Energy production would shift dramatically, as altered mass energy equivalents would necessitate entirely new principles, focusing on hyper-efficiency, novel material properties, and alternative power sources far removed from our current high-yield methods. Optical engineering would confront a true paradox. Designing even basic lenses, cameras, or telescopes would be monumental, requiring a complete overhaul of principles to manipulate photons that overtly lag and distort. Every technological advance would be a battle against the fundamental slowness of information itself, forcing humanity to innovate in incredibly novel and localized ways. In a universe where light crawls, life itself would undergo profound evolutionary changes. Vision, as we know it, would become a complex, delayed experience. Organisms would evolve specialized sensory systems to process these lagging, distorted visuals, perhaps developing anticipatory neural networks or relying more heavily on immediate senses like sound and touch for environmental feedback. Consequently, cognitive architectures would adapt. Brains would inherently optimize their processing of time, memory, and reaction speeds, fine-tuning for a reality where now is a constantly shifting concept, fragmented by slow information flow. This constraint would deeply reshape human interaction. Social structures, economies, and even conflict would demand unprecedented patience and localized strategies. Collaboration across distances would be incredibly challenging, fostering highly self-sufficient communities and fundamentally altering the very essence of coexistence distance and global connection. A slower light speed would redefine reality itself. In your opinion, what if the speed of light was slower? Share your thoughts in the comments.